In this lab, we are going to see what happens and which network design rules we have to consider if we connect this MST region 1, 2, 3, to another group of switches which run rapid pvst+. So MST is backward compatible with regular PVST or rapid PVST, so these networks can work together, and the MST region will appear like a regular PVST domain for the other switches, and it will send regular PPDUs for every VLAN. This is what's called pvst-simulation mode. But we have to keep some simple rules and design the network according to these rules. Otherwise, we can run into pvst simulation failure when switch 2 and switch 3 block the port towards the pvst plus domain to prevent loops, and the two networks can't simply work together. So what are these rules and how should we design this network is what we will talk about in this video. First, let's start with the MST domain. Switch 1, 2, and 3 run multiple spanning tree, and they are in the same region. Here is the configuration regarding spanning tree. I'll show running config pipe section spanning tree. So the name, the revision number, and the instance to VLAN mappings are the same on each switch, as you can see. So I created 4 VLANs besides VLAN 1, VLAN 10, 20, 30, and 40, and they are mapped to 2 different MST instances. So we have 3 MST instances within the MST region. Show spanning tree MST. Instance 0, or the IST, is mapped to VLAN 1 and every other VLANs which are not used. Instance 1 is mapped to VLAN 10 and 20, and instance 2 is mapped to VLAN 30 and 40. And we use the same VLAN 2 instance mapping on the other 2 switches as well, so on switch 2 and switch 3 as well. The links between the switches are trunk links. I'll show interfaces trunk. So all VLANs are allowed on every link, and we don't use VTP pruning or manual pruning or anything like that. In the PVST domain, the situation is similar. I'll show interfaces trunk. We have the same 4 VLANs created. All links are trunk links with the usual A.2.1q encapsulation, and here we have 5 separate STP instances. I'll show spanning tree root, so VLAN 1 and the 4 custom VLANs. So let's say that we want to extend the MST network with these PVST plus switches and connect them this way. So G02 on switch 2 to G02 on switch 4 and G02 on switch 3 to G0/2 on switch 5. Actually, these interfaces are not enabled yet, they are shut down, because before I enable them, I'm gonna start packet capture on both of these links. And let's determine beforehand which switch is going to be the CIST route if I no-shut these interfaces. So we have two choices. The CIST route is either in the MST region, which is the recommended way, or in the pvst plus domain. And to determine the CIST route, the IST or MST instance 0 is compared to the VLAN 1 instance in the pvst domain. And the rule here is the same as always. The switch with the lowest bridge ID is going to be the CIST route. So the bridge priority is the same on all switches. So 32,768. I haven't changed that. So we have to compare the base MAC addresses and the lowest value wins. I have already written them under these boxes so that we can compare them easily. And switch 1 has the lowest value, which begins with 0C42. So by default, the CIST route will be in the MST domain. And if the CIST route is in the MST domain, all the other STP instances in the pvst domain, so VLAN 2, 3 and above, must have a bridge ID higher than the CIST route. Otherwise, we will encounter the pvst-simulation failure. And G02 on switch 2 and G02 on switch 3 will turn into the blocking state. So, as I have said, only VLAN 1 is compared to the IST. But there is this requirement regarding the other STP instances. So they should be inferior to the CIST route. And by default, in this topology, they are, because they have a default priority of 32,768. And every switch has a higher base MAC address than the CIST route. So the CIST route should be switch 1. So let's no-shut these interfaces on each switch and let's see what happens. Actually, first I'm gonna configure this link as a trunk link with .1 queue, because by default this interface G0/2 would be an access port. So interface G02 switch port trunk encapsulation .1q switch port mode trunk and no shutdown. And we issue the same commands on the other side as well. And I do the same thing for this link between switch 3 and switch 5. And let's see which one is elected as the root bridge or the CIST route. On switch 1, show spanning tree MST. Switch 1 is claiming that he is the CIST route. That is what we have expected. Let's verify on the other switches as well. Let's check it on switch 6, for example. Show spanning tree. 0C42, which is switch 1, is the root bridge for VLAN 1, and he's the root for the other VLANs as well. On switch 2, show spanning tree MST, we can see that the interface G02 is marked as a boundary port running in a pvst-simulation mode, which means that switch 2 is generating a BPDU for each separate STP instance and for each VLAN in the PVST domain, so that the PVST switches can also understand these. And here is the Wireshark capture between switch 2 and switch 4. The source MAC address of these frames are 0CB1, which is the interface of switch 2. So switch 2 is generating these BPDUs, one for each VLAN, because this is what the switches in the PVST domain are expecting from the other switches. See, the originating VLAN, VLAN 1, VLAN 40, 30, 20, and VLAN 10. And the frames are also tagged with the regular 802.1q VLAN tag, because these are all trunk links. So switch 2 is claiming that the root bridge is 0C42, which is again switch 1, and the root path cost is 0 for every single VLAN. So switch 2 hides the internal topology within the MST region, because it has an internal path cost of 20,000, which is the cost to the CIST root. So the cost of this link. And still he advertises a cost of 0. So it doesn't really matter where the CIST root is located within the MST region. Similarly, on this link between switch 3 and switch 5, switch 3 is advertising the same thing, bridge ID 0C42, which is switch 1, and the cost is 0 for every VLAN. So both switch 4 and switch 5 are going to choose their G0/2 interface as their root port, if I am not mistaken, because both are receiving a BPDU with a cost of 0 from the MST region. Let's verify on switch 4, show spanning tree, and indeed interface G02 is the root port on switch 4 for instance VLAN 1, and for the other spanning tree instances as well, VLAN 10, VLAN 20, 30, and VLAN 40. And on switch 5, show spanning tree, G02 is also a root port on switch 5, G00 is an alternate port here, so we are blocking this link, and the port roles and port states should be the same for every other VLANs as well. And on switch 6, the root port should be G00 because switch 4 has a lower bridge ID than switch 5. So let's verify, show spanning tree, and indeed G00 is the root port in the forwarding state, and G0/1 is blocking. Now, according to the first rule, if the CIST root is in the MST region, the bridge ID for all the VLANs must be higher than the bridge ID of the CIST root. And currently, this rule is met. But if I change the priority of any STP instance for any VLAN, not just VLAN 1, on basically any switch in the pvst domain. So if I make priority lower than 32,768, the pvst-simulation failure should be triggered on both switch 2 and switch 3. And these ports G0/2 on both switches will be blocking. So let's choose a switch and VLAN, or switch 6, for example. If I lower the priority of the STP instance of VLAN 20, for example, like this, spanning tree VLAN 20, and the priority, and any value lower than 32,768, let's make it 4096. And if I press enter here, this should trigger a pvst-simulation failure. Let's move back to switch 2, and indeed, the moment switch 2 and switch 3 as well received the superior BPDU from the pvst domain, they both shut down the port G0/2. Show spanning tree MST, and the state of the boundary port is now broken on both switches. In the description indicates that we have received an inconsistent BPDU. Now it works similarly to rootguard in a way that if it stops receiving these superior BPDUs after the max H time, so after about 20 seconds, it unblocks the port. So if I move back to switch 6 and change the priority back to the default, so spanning tree VLAN 20, and the priority is the default value, 32,768. And when the max H timer expires, so in about 20 seconds, we should receive a syslog message indicating that the port is unblocked. And here it is, pvst-simulation inconsistency cleared. Show spanning tree MST, and the port is designated again. And it should move to the forwarding state. Now what if the CIST root is in the pvst domain? Again, MST instance 0 is compared to VLAN 1 instance, and the lower bridge ID wins. So let's make switch 6 the CIST route, for example. So on switch 6, we should lower the priority of the VLAN 1 instance. So spanning tree VLAN 1 priority, and let's make it 4096. We won't make it 0 because it wouldn't work that way, and I will show you why shortly. And by the way, this configuration should also fail, but let's try and verify on the boundary port on switch 2. So show spanning tree MST. The boundary port is now blocking, but it has the alternate role, so nothing is wrong here. On switch 3, we can already see that something is wrong. Again, pvst-simulation failure. We'll show spanning tree MST, and G02 is a root port now, which is understandable. It is facing upstream, the CIST route, but again, it is broken. So how can we resolve this issue? So if the CIST route is not in the MST region, every single STP instance for every VLAN besides VLAN 1 must have a lower bridge ID than VLAN 1. That's why I made it 4096, so that we can lower the priority of the other instances. And let's do that. Spanning tree VLAN 10, 20, 30, and 40, and priority 0. And now the boundary port should be forwarding again. Oh, move back to switch 3, and as we can see, pvst-simulation inconsistency cleared. And now interface G0/2, instead of being the root port, it has this new role for instance 1 and instance 2 called master port. And this is basically facing the CIST route upstream, and it provides connectivity for every single VLAN on this trunk link towards the pvst domain. So switch 3 is now also the regional route for instance 0. So what does this mean? It's basically the closest switch to the CIST route. When the CIST route was in the MST region, the CIST route and the regional route was the same switch, so switch 1. Now both switch 2 and switch 3 have the same external route path cost. So show spanning tree MST 0 and show spanning tree MST 0, 20,004 and 20,004. That's because these switches in the pvst domain use the short path cost method, while the MST switches use the long one. So 20,000 is the cost of this link, and 4 is the cost of this gigabit link. So both of them have the same cost, but this one has a lower bridge ID. So switch 3 was elected as the regional route, for instance 0 or the IST route. So again, to summarize, remember that if the CIST route is outside of the MST region, every single STP instance must have a lower priority than the VLAN 1 instance. That's what we have configured on switch 6. We'll show running config section spanning tree. So VLAN 1 has a priority of 4096, and every other VLAN has a lower priority on switch 6.